Today I will talk about circular linked lists. Last week we told about linked lists. Let me remind you about the linked lists. So this is our node, and we have more than one node in a linked list, and they are connected to each other. And the last node includes null, so we can understand that it's the last node. And we were always keeping the first node. So we know how to access the first element. Therefore, we can manage the nodes in our linked list. And these nodes are connected to each other. And we can solve our problems by using linked lists. Okay? This is linked list. We are calling it linked list. Now I will talk about circular linked list. So what is the difference between circular linked list and linked list? When, look here, when instead of null, we connect the last node to the first node. So we are calling it circular linked list. That's the difference of, okay? When we say circular linked list, we can understand this structure, okay? Everything is the same. We have nodes, we have connections, we can insert new node, we can delete a node, we can do whatever you want as you did in linked list. But the difference is last node is always connected to the first one. Okay, this is the idea. And here, actually, when we are using a circular linked list, you can keep the first and the last at the same time, or the first one. But I generally prefer to keep the last node. Okay, the last node for circular linked list. But it depends on your solution. Okay, you can manage this. But in my exercises, I will keep the address of the last node always. Okay. Now, let's solve an exercise about that. Let's say that I want to write a function to add a new node to the end of my circular linked list. Okay, let's say that we have this linked list. Okay, we have 10, we have 20, and we have 30 here. And I want to add a new node at the end. Okay, so whenever I add a node, it will be added to the end. Okay, how we can do that? First of all, okay, we are creating a node. Okay, but before that, if we are focusing on insert function, we need to consider if I have any node in the circular linked list. Because if I don't have any node, so this insert will create a node, and that one will be my last node, isn't it? I said that I will store the address of the last node with list always, okay? So this is important for me. If I have nothing, let's say that I have nothing in my list, I will create a node, okay? And this node is the first and last node at the same time. So this will be my list. So if the list is empty, I need to do that. Okay? I need to consider this one. If list is not empty, so we have at least one node, then I will create a node. I will connect my node, and this one to this, okay? And then this one will be connected to this, and list will point this one, okay? Okay, this is what I'm going to do. Okay, let's start over. Now here, let's say that I'm going to write my function. Okay. Okay, now I will use void for my inset function because I will not return value back. So I can say void, but I will have two parameters when I call this function. Therefore, I need to write two arguments here. The first one is, I mean, since I'm going to insert new node at the end, so the first one will be list, okay? List that contains the address of the last node. So I will declare it as node ptr pointer pq. Why I said pointer? Because as I said to you, when you insert a new node to the end, what I said, we are changing the position of list. So when you are changing position of list, and list is a pointer, we need to change the content of list pointer. So in the function, if I want to do that, I need to declare it with as pointer, because this pointer will point list pointer. So we have pointer to pointer. And when I modify PQ, the content of list pointer will be modified. That's why I am declaring it as pointer here as well. Okay. So this pointer PQ includes the address of list, will include the address of list. So when I change this, list itself will be changed. And I need to do that in the function because I'm moving list to the end always. Okay. Okay. The next one is, since I'm going to insert a new node, I need to use it for the value. Let's say that I will insert an integer value. So I will say integer value here. And my function. Okay. Then the first thing is, friends, I didn't put the declarations here. I will say struct node, and here what we'll have curly brace, and I will have integer info, struct node pointer next, and I will say type def struct node pointer node ptr. Okay. Actually, this is circular linked list. The last node will be connected to the first one, but in the structure, since it is one directional, I mean, every node always points the edit node, I mean, the node on the right-hand side. I don't need to make any change here. So still the same structure solves our problem. Okay? So I don't need to change it. I can keep it. But in further explanations that I will talk about other type of circular linked list, I will change this structure node. Okay? I will change this structure. Okay. Then let me write get node function as well because I will use it. Get node. Here, no need for any parameter. So I will say node ptr p, and p is equal to malloc. Remember this. Node ptr. Actually, I describe all these things in our previous lectures. Size of. So I'm not going to spend time to explain these things again. You can check our previous notes. And return Okay, here just I need to add one more library because I used malloc. So I will say include stdlib.h. Okay. Now I'm going back to my insert. Okay, let's go to insert function. First of all, what I said that we need to check if my list is empty or not. Okay, so I need to consider this. What I'm saying, I will check it if PQ is equal to null or not. If it is equal to null, then I can understand that it's empty. Okay, this is the condition that I can use to check if it is empty or not. But if it is empty, I'm going to create the first node and make it as a last node. It's also a last node, so I will change my list pointer. Okay. So before this condition, I need to create my node. So here, node ptr t, and t is equal to get node. I'm creating it. And then I will assign the value to its info. Info is equal to value. Okay, so my node is ready here. And when I check it and I see that it's empty, I will say pointer pq is equal to p. Okay, that's all. So when I do that, the first node, let me go back here. Let's say that we have a list, okay? We have a list and it is null. We have a list and it is null. We don't have any node here, okay? In the main, when we initialize our list, in main, when we initialize our list, we are saying list is equal to null, okay? We are saying this when we initialize it, okay? Therefore, when we call insert function first time, so list will be null. So when list is null, it will enter into this let's say the program fragment. So it will say that PQ is equal to P. Okay, when I call it first time, it creates the node. Let me create it here. It creates the node, puts the value in it. Let's say that it is 5. Okay. Okay. This is info. This is next. Okay. And after that, PQ is equal to P makes this list will include the address of the first node. Okay. And it's not finished. It's not finished actually. Here, after I do that, this is a circular linked list. I need to create this. I need to create this link. Okay. So here, I will say PQ next is equal to T, isn't it? T is the created node. PQ is my list. So my list next should point itself. P actually. But in this situation, it's itself. Okay? And then here, it's not, yes, I think that's all. Okay. Okay. Then let me tell you other thing. if the list is not empty. So let's say that my list points this one because we have single node and it's the last node as well. And I'm calling insert to insert a new value. Let's say that I want to insert 50. Okay? I'm calling insert one more time. Okay? So when I call insert, what happens? First of all, it will create a node here. Okay, let me create the node. Let me create the node. It creates a node, puts 50 here, okay, and waits. Then here it checks if PQ, assume that we called our insert function in this way, insert address of list 50, okay. Here, if PQ is null, it's not null because we have node in the circular linked list and list includes an address. It's not null, so it will skip this part. So I need else part, isn't it? So if this condition is false, I want to do this, else t next is equal to PQ next. Okay. In this situation, T is the node that I created in insert. Okay? So P next is equal to PQ next. PQ, what is PQ? PQ is this. So PQ points list points this node. So this node's next will be assigned to P's next. So what is this node's next? It points itself. So this address will be broken and it will be copied into P's next. So P will point the first one. Okay? If there is a node in your linked list, I want this to happen. Okay? But it's not finished. When it goes outside the else part, then this statement will execute. What is this? PQ's next is equal to P. PQ points list points first node, so the next of this will be equal to P. Okay? Is that all? No. In this situation, I need to update list always. Because what I said to you, list will point the last node always. So here I am inserting last node, therefore I need to update PQ always. So I need one more statement here to update PQ. So PQ is equal to list. So what happens here? PQ is equal to list. So the list will not point here. The list will point this. Okay? So this is what I want. So when I quit from insert, what happens? Everything will be gone. And list will be here by pointing the last node. Okay? And this insert function works when the list is empty, when you have nodes in your list, doesn't matter. This insert function works for all type of, all situation of your circular linked list. Okay? But in this structure, you have nodes. The last node is connected to the first one. and list points the last node always, last inserted node always, okay? This is the idea. Any question? Okay, that's good.